Hi everyone, my name is Amit. I'm on a mission of making AI so simple that anyone can understand it. In last few episodes, we are talking about the techniques to overcome the overfitting in our AI models. As part of that, we have talked about XGBoost. In this episode, I'm going to talk about another algorithm called Adaptive Boost, also known as Adaboost. Let me show you. So this is our training data x1, x2 and y variable. This is a classification problem. In Adaboost, we simply assign a weight to each row initially, and that weight is calculated by 1 divided by number of rows, 0.2 to each row. Then what we do, we train a decision tree with depth 1, that is called stump also. How do we train a decision tree on this data? Either take x1 variable or x2 variable and then whichever column we select to divide that decision tree like this. In detail, if you want to understand how this decision tree is created using Gini index, watch episode 18. As stage 1, we train a decision tree on this data and we do a prediction. So the prediction came as 1 1 0 0 0. So we can see there are two wrong answers for second row and for third row. As part of boosting, we tell this error to the next model. How do we do that? Before doing it, we need to calculate one component that is called alpha. Alpha is the amount of say a model can have. So if the error rate is high, the value of alpha has to be very low, and if the error rate is low, the value of alpha has to be very high. What is that function? The function is like this: 1 by 2 ln 1 minus error divided by error. How do we calculate the error? We simply add the weights of all the misclassified components. So we know that there are two rows, model made an error, 0.2 plus 0.2 came as 0.4 as the error, and when we plug in the values in this formula, we get the value as 0.2. In stage 2, we will tell the next model that hey, these are the rows where we made error using model M1, so please pay more attention on it. And how do we do that? A technique called upsampling. For misclassified components, we again calculate the weights as current weight into e to the power alpha, and for correctly classified components, we calculate current weight into e to the power minus alpha. So this is our data, and these are the new weights. Okay, we calculated using these above two formulas, and for misclassified row, you see the weights are increased. We pay more attention to these rows.